All right, so here are some practice problems from the last lesson that we talked about. Go ahead and try these four, and then we'll get into some proofs using these special angles. All right, so I know these are same side interior, so that means they're supplementary, so I know 73 plus x plus 123 is equal to 180. All right, so I'm going to combine like terms, so I get 2x plus 196 is equal to 180. Subtract 196 from both sides. Oops. I get 2x is equal to negative 16. X is equal to negative 8. All right, same thing here. All right, they're same side interior, so I'll do it over here. 80 plus x plus 105 is equal to 180. I'll add like terms. X plus 185 equals 180. Subtract 185. And we get x is equal to negative 5. All right, these are consecutive angles. If I cover this up, this is in the bottom left. If I cover this side up, this is in the bottom left. So we know these are equal. So 4x plus 22 equals 70. Subtract 22. 4x is equal to 48. Divide 48 by 4, and we get 12. Okay. Then these are alternate exterior angles. Since they're alternate, that means they're equal. So, or congruent, so 6x plus 2 is equal to 7x minus 6. So I'll add 6 on both sides, subtract 6x, and we get 8 is equal to x. All right, and we're done with those four. All right, so we're going to use that knowledge to do these proofs. Yay! Okay, so first step, so we're given that AB is parallel, or A and B are parallel. Okay, and we know this is a transversal because it's going through the parallel line. Now, I know angle 1 is congruent to angle 5 because of consecutive angle theorem. Okay, so we're proving the alternate interior angle theorem. Because, right, we could just go straight here and do 4 and 5. Okay, there's alternate interior angle theorem, duh. Okay, but we're going to use the consecutive angle postulate to prove that. So then angle 4 and angle 1 are congruent because they're vertical angles. Okay, and we know measure angle 4 is equal to measure angle 5 because of the transitive property. I'm just gonna put transitive. And we'll put prop. All right, pretty easy, right? Let's keep going. We're gonna prove the alternate exterior angle theorem now. So we know 2 and 6 are congruent because of the consecutive angle theorem. We know 5 and 8, not 6. 6 and 8 are congruent because of the vertical angle. They're vertical angles. That little symbol is an angle. Okay. And then same thing, we know 2 and 8 are both equal to angle 6. So we know this because of the transitive property. Too easy. Let's keep going. Same thing, same side interior. Okay, we're trying to prove that angle 4 and angle 6 equals 180. So I know angle 2 and angle 4 equal to 180 because they are linear pairs. So definition of linear pair. Okay, I know 2 and 6 are congruent because of the consecutive angle theorem. All right, and then I know 4 plus 6 is equal to 180 because of the substitution property. And we're done. All right, let's do another one. Same thing, same side interior. Okay, we're trying to prove that angle 2 and angle 7 added together equals 180. So let's do this first. We're gonna do, we're trying to relate 2 and 7. So we want to do, we know the measure of angle 6 plus the measure of angle 7 equals 180. So that's definition of linear pair. Okay, and then we know 6, the measure of angle 6 equals the measure of angle 2 by consecutive angle theorem. And then we know the measure of angle 2 plus the measure of angle 7 equals 180 by substitution property. All right, and keep going. All right, so go ahead and try this next one on your own. Pause the video, try it, and then play it. All right, so you should try it on your own. This first one is given, always. So I know angle 1 and angle 3 are consecutive angles. So consecutive angle theorem. I think I misspelled consecutive, sorry. And then I know 2 and 3 are congruent by vertical angle theorem. And then I know 1 and 2 are congruent by substitution or transitive. We'll put transitive. All right, so this looks crazy, but it's not. It's actually pretty fun. It's like two parallel lines that are also transversals of each other. It's pretty awesome. So this is given, okay? We know angle 4 is congruent to angle 14, okay? Because they're alternate. So alternate interior, or exterior, sorry. Angle theorem. And then we know 14 and 16 are congruent because of the, what do you call it? Consecutive angle theorem. And then we know 4 is congruent to 16 because of the transitive property. So hopefully that's what you got. Let's see. Because, yeah, by looking at this normally, right, we wouldn't associate 4 and 16 together at all. But we can because of the theorems. Okay, let's keep going. All right, so 4 is congruent to 14. That is given. All right, and we know M is parallel to N. Let's skip. Well, let's not skip it. Okay, so with every single one of these theorems, the alternate, or not the alternate, they're also, the converse is true. So if I know these angles are congruent, 4 and 14 are congruent, by the alternate interior angle converse, I know these two lines are parallel. So it's just the opposite. So since I know these are congruent, I know these two are parallel. So we'd still say alternate exterior, because they're exterior angles, angle theorem, but we need to add the word converse to it, okay? So, yeah, so I would work through this one first, then have you guys try these next ones, okay? So now that I know these two lines are parallel, I can say, okay, Oh, this is actually also given, sorry. Given, but since I know these are parallel, I know 8 and 9 are same side interior. So same side interior says that they are supplementary. So same side interiors theorem, angle theorem. That looks like an L, it should be a C, okay? Then I can set these two equal because they're both equal to 180. So this is the transitive property. Then I subtracted the 2 8s and got that. So this is a subtraction property. Ooh. Of equality. All right. And then again, since I know 9 is congruent to 11, okay, I can then say that these two are parallel. So these are same type, but they're consecutive. So this would be consecutive or corresponding consecutive angle theorem, but you need to add the word converse whenever you're proving something is parallel. Okay. So notice how we're proving something's parallel again. So you guys try this next one. Just know on this last step you're going to use the word converse at the end if you're trying to prove something is parallel. So go ahead and try these. All right. So this is given to me. Since I know these are parallel, I can know that 1 and 2 are supplementary because this is a transverse going through these two, so this is the same side interior. Angle theorem. All right, and then I know 1 and 2 by definition of supplementary. They're equal to 180. Then I know angle 1 and angle 3 are congruent because it's given. So just be careful if you feel like they're pulling something out of thin air. It's probably because it's also given. All right, and then since 3 and 2 are equal to 180 as well, because of the substitution property. See, they just substituted the 3 in for the 1. So I know these are supplementary by definition of sup. I'm just gonna say sup if that's okay. And then the last one, since we know these two are supplementary, we can conclude that these two lines are parallel by the same side interior angle theorem, but we have to use the word converse whenever we are proving something is parallel. Okay. All right, these last two should be super quick. Go ahead and try these last two on your own. All right, the first step, always show what you're given. So 2 is congruent to angle 3. Given. Angle 2 is congruent to angle 1, vertical angles. So angle 1 is congruent to angle 3 by substitution or transitive. Let's do transitive. Prop. Should have added vertical angle theorem. All right, same thing, angle 4, angle 6, because of given. We know angle 4 is congruent to angle 5 because vertical angle. And then we know these two are congruent because of transitive. So angle 5 is congruent to angle 6 because of transitive property. There you go. All right, so that's how proofs look with special angles.